Hi, everyone. Welcome to the Pure AI podcast, where flesh and blood journalists do the legwork and AI swoops in for the last mile audio conversion. I'm John K. Waters, editor in chief of the Converge 360 group of 1105 Media, and joining me, as always, is our fearless leader and the editorial equivalent of an all-night codathon, Gladys Rama. Hey, Gladys, how's it going?
Hi, John. It's been another long week in the AI trenches. I've read so many papers on generative models, I'm starting to dream in tokens. So, what's on deck today?
OpenAI has introduced its new GPT 4.1 model family, which is a significant evolution of their model lineup. They announced three variants: GPT 4.1, GPT 4.1 Mini, and GPT 4.1 Nano. And what's fascinating is how they've managed to improve performance while actually making these models more cost-effective and faster.
What would you say is standing out most for you about these new releases?
Well, for the GPT 4.1 family, I'm most impressed by the massive improvements in code generation capabilities. Like, the accuracy jump on SWE Bench Verified is incredible, from 33% with GPT 4.0 up to 54.6% with GPT 4.1. That's just that's just huge for developers. And the ability to handle up to 1 million tokens of context across all the models, that's going to enable so many applications that were just impossible before.
And then there's this image generation model they're adding to the API. That's got to be exciting for a different set of developers, right?
This is the model that's been powering image generation in ChatGPT, and now developers can integrate it directly into their own applications. It's called GPT Image 1, and it's natively multimodal, which means it can understand both text and images together. The adoption has been crazy fast, too. OpenAI reported users generated over 700 million images just in the first week after it launched in ChatGPT. And now companies like Adobe, Figma, Airtable, they're all building with it.
Okay, so for our listeners who maybe aren't developers but are interested in AI, why should they care about these announcements? What's the bigger picture here?
That is a great question. I think what we're seeing is AI becoming more capable and more accessible at the same time. These models can understand more context, follow instructions better, and generate both text and images with higher quality. And for the average person, that means the AI powered tools they use every day, whether it's chatbots, design tools, or productivity apps, are going to get dramatically better and more useful. We're really seeing the foundation for the next generation of AI applications being laid right here.
And I'm guessing that's why OpenAI emphasized the real world utility of these models in their announcement, right?
Yes, that's right. They specifically mentioned collaborating with companies like Thomson Reuters, Carlyle, Blue Jay, and Windsurf to make sure these models solve actual problems people have. It's not just about impressive benchmarks anymore, though the benchmarks are impressive too. It's about creating AI that can do useful work in specific domains like legal analysis, customer support, and generating code that actually runs. The era of general purpose AI that's actually useful enough to trust with real tasks it's finally here, and that's what makes these announcements so exciting.
So let's dive deeper into this GPT 4.1 family. What exactly are we looking at with these three new models?
Yeah, so OpenAI has really thought about different use cases and needs with this lineup. You've got GPT 4.1, which is like the flagship model, and then GPT 4.1 Mini and GPT 4.1 Nano. And they're all, designed with this balance of intelligence, speed, and cost in mind.
I'm curious about what makes them different from each other. Is it just size, or are there other factors?
It's definitely more than just size. So the main GPT 4.1 model, that's their most powerful offering right now. It's got all the bells and whistles, exceptional reasoning, really strong code generation, amazing instruction following. But the mini and nano versions, they're not just scaled down versions, they're actually optimized differently.
Okay, so what kind of optimizations are we talking about?
So the GPT 4.1 mini is really about finding this sweet spot between capability and speed. It cuts latency in half compared to the full model while still maintaining intelligence comparable to GPT 4.0. That's that's pretty impressive engineering, right? They've managed to make it respond much faster without sacrificing too much of the intelligence.
And what about the nano version?
The Nano is perfect for mobile applications and anywhere you need lightweight inference. It's super fast, responses in under 5 seconds, and offers the best price performance ratio they've ever had. So if you're building something where cost and speed really matter and you don't need the absolute cutting edge reasoning capabilities, Nano is going to be your go to.
Okay, so what's really standing out to me is this focus on autonomous agents. Can you explain a bit more about what that means in practice?
Sure, autonomous agents are basically AI systems that can perform complex tasks across different domains without constant human guidance. Imagine an AI that can not only understand a legal contract, but analyze it, find problems, suggest changes, and explain its reasoning. Or an AI that can look at your code base, understand what you're trying to do, and help refactor it or add new features.
That seems like a pretty big shift from just answering questions or generating text.
Well, that's why these models were designed with that specific use case in mind. OpenAI says they trained these models with a focus on real world utility, collaborating with companies in different sectors. Thomson Reuters is using it for legal analysis, Carlyle for financial report analysis, Blue Jay for legal tech, and Windsurf for code generation.
Are there any specific examples of how these companies are seeing improvements?
Oh, yeah, the numbers are actually pretty impressive. Windsurf reported like a 30% improvement in tool use efficiency and a 50% reduction in redundant edits when working with code, and that directly speeds up development cycles. BlueJ saw a 53% jump in complex scenario comprehension for legal applications, and and Carlyle reported a 50% accuracy boost when extracting data from large financial reports.
So we're not just talking about incremental improvements here.
Not at all. These are substantial gains that actually change what's possible. When you combine the intelligence improvements with the ability to handle up to 1 million tokens of context, you get systems that can truly understand and work with whole code bases, entire legal contracts, or massive financial documents. And that's a game changer for enterprise applications especially.
And how about the cost factor? That's always been a consideration with these larger models.
GPT 4.1 is apparently 26% more cost efficient than GPT 4.0 on average. And they've removed the additional fees for long context usage, which is huge for applications that need to process large documents. They've even increased prompt caching discounts from 50% to 75%. So you're getting more capability at a lower cost, which opens up so many more use cases.
Um, so I'm a bit confused about OpenAI's naming strategy lately. They had GPT-4, then GPT-4o, then we heard about GPT-4.5, and now we've got this GPT-4.1 family. What's going on with all these names?
Yeah, so OpenAI has kind of moved away from that strict version numbering scheme they used to have, and they've started using these internal code names too, like Orion, which became GPT 4.0. It's made the lines between model generations a bit blurry.
So is GPT 4.1 just like a minor update to GPT 4 because that's what the name kind of suggests to me?
That's exactly what makes it confusing. Despite the name making it sound like a point release, GPT 4.1 is actually way more significant than that. Think of it this way: GPT 4.5 was probably this internal stepping stone, like an experimental version they were testing. And GPT 4.1 is basically taking all those capabilities and formalizing them into a production ready model.
What's the relationship between all these models then? Like how does GPT 4.1 compare to GPT 4o?
So GPT 4 was focused on multimodality. handling text, images, and audio in this really seamless way. GPT 4.1 builds on that foundation, but really doubles down on things developers need most: better code generation, better instruction following, and that 1 million token context window. It's like they took all the lessons from GPT-4 and GPT 4.5 experiments and refined them into something really practical.
And they're actually retiring GPT 4.5, right? What's that about?
They're retiring GPT 4.5 preview on July 14th this year. That model helped them explore some really ambitious capabilities, but GPT 4.1 is bringing those into full production maturity. So if you've been using GPT 4.5 preview, you'll need to migrate to GPT 4.1.
I'm curious about what this means for developers. Like, if you're building something on OpenAI's API, how should you think about all these different models?
Great question. For developers, I think the key takeaway is that GPT 4.1 is now the gold standard if you want the best performance, especially for code heavy applications or anything that needs to process lots of text. But you've also got these mini and nano versions that give you more options depending on your latency and cost requirements.
So it's almost like they're creating this product family instead of just one model.
It is more of a product family approach, and I think this is smart from a product perspective. Developers have different needs. Some need raw intelligence, others need speed, others are super cost sensitive. This lineup lets you choose the right tool for your specific job.
And does this naming strategy tell us anything about what might be coming next?
I think it does, actually. It suggests they're moving to a more mature product development cycle with these clear tiers of offerings. I wouldn't be surprised if we see future models following this pattern of a flagship version plus mini and nano variants. And And I think the fact that they're becoming more deliberate about what makes it into production versus what stays experimental is a good sign for stability. Developers need that predictability when they're building serious applications.
Let's switch gears a bit and talk about what's probably the most exciting aspect of GPT 4.1 for many developers: the improvements in software engineering capabilities. I'm seeing some pretty impressive numbers here.
Oh, absolutely. This is where GPT 4.1 really shines. So the benchmark results are actually kind of mind blowing. It's achieving 54.6% accuracy on SWE bench verified, which is, a really challenging software engineering benchmark. That's up from just 33% for GPT 4.0. So we're talking about a massive leap forward.
Wow, that's a big jump. What does that mean in practical
So, in
terms?
practical terms, it means GPT 4.1 is getting much, much better at understanding code bases, making the right edits, and actually fixing bugs correctly the first time. It's also really strong with multi language code editing tasks, which is huge for developers working in modern tech stacks where you're, jumping between JavaScript, Python, maybe some SQL, and, and other languages all the time.
Are companies already using this for real projects, or is this still kind of experimental?
No, companies are definitely already putting this to work. One of the early testers, Windsurf, reported some pretty incredible efficiency gains. They saw 30% better efficiency in how the model uses developer tools and a 50% reduction in redundant edits. What that means is their development cycles are getting way faster.
So, what does that look like for a developer on a day to day basis?
Picture this: you're working on a complex feature, right? With previous models, you might get code that compiles but has subtle logical errors, or the AI might miss important context about how your code base is structured. With GPT 4.1, you're getting much more accurate suggestions that actually understand your project's architecture and patterns.
I'm guessing this is especially helpful for more junior developers.
Absolutely, but it's not just junior devs who benefit. Even senior engineers are finding it valuable because it handles a lot of the repetitive coding tasks that nobody really enjoys. Things like writing boilerplate, adapting code patterns across files, or implementing standard features. The AI is getting good enough that experienced developers can focus more on the creative and architectural aspects of software development while letting GPT 4.1 handle more of the implementation details.
Are there specific types of programming tasks where GPT 4.1 is especially strong?
Great question. From what we're seeing, it's particularly strong at refactoring existing code, implementing features based on natural language specifications, and debugging. One really impressive capability is how it can take a bug report or error message and not just identify the issue, but actually generate the fix.
What about more complex projects? I mean, real world code bases can be huge and complicated.
That's where that million token context window comes in. GPT 4.1 can literally ingest entire repositories or massive code files and maintain understanding throughout. So it can make changes in one part of the code base while being aware of dependencies and patterns elsewhere. And that's something previous models really struggled with.
So it sounds like we're getting closer to having AI that can actually function as a real coding partner.
Yeah, I think that's a good way to put it. We're not yet at the point where it can replace developers, but we're definitely moving toward AI that can be a truly collaborative coding partner. The efficiency gains are real. And for teams adopting these tools strategically, they're seeing meaningful acceleration in their development cycles.
So I'm curious about something else. I've heard that GPT 4.1 is much better at following instructions now.
This is actually a huge deal, and it's something that wasn't getting as much attention initially, but is very important for real world applications. GPT 4.1 has made some impressive gains in instruction compliance, especially when it comes to multi turn conversations and format sensitive prompts.
What kind of benchmarks are they using to measure that?
So they're using Scale AI's multi challenge, where GPT 4.1 scores about 38%, which doesn't sound amazing on its own, but when you compare it to earlier models, it's a significant jump. And OpenAI's internal instruction following evaluations show even more dramatic improvements. The key thing here is that it's getting much better at understanding exactly what you want and sticking to that format or approach throughout the entire interaction.
Can you give me an example of what that might look like in practice?
Yeah, so imagine you're building a customer support system where you need very specific formatting for the responses, right? Maybe you need the AI to always include certain disclaimer text, or categorize issues in a particular way, or follow a specific troubleshooting protocol. With previous models, you'd often find them slowly drifting away from your instructions over multiple turns of conversation. GPT 4.1 is much more consistent at maintaining those patterns.
What about more creative tasks where the instructions might be less structured?
That's where it gets even more interesting, to be honest. For creative work, GPT 4.1 is better at balancing creative freedom with the specific constraints you give it. So if you're generating marketing copy and you specify certain keywords or messaging guidelines, it's much better at working within those boundaries while still producing engaging content.
I'm wondering if this has applications for coding as well, since we just talked about that.
Oh, 100%. For coding, this means if you explain your specific coding standards or architectural patterns, GPT 4.1 is much more likely to adhere to those consistently. So if you say, use the repository pattern or follow this error handling approach, it will maintain that pattern throughout the entire code base, not just in the first few functions it generates.
Do you think this is part of why they're positioning this for agentic systems?
For autonomous agents to be reliable, they need to follow instructions precisely and consistently, like an agent that's helping manage your calendar or responding to customer inquiries needs to maintain the same behavior patterns over time. GPT 4.1's improvements in instruction following make it much more suitable for these kinds of persistent, autonomous tasks where reliability is essential.
I guess the big question is how much better does this make the overall user experience?
Based on what we're seeing from early adopters, it's a night and day difference in certain applications. When users don't have to constantly re explain what they want or correct the AI's approach, the entire interaction becomes more efficient and, and less frustrating. I think that's the real breakthrough here. It's not just about following instructions perfectly, It's about creating a more seamless and productive collaboration between humans and AI.
So, I'm really interested in this idea of handling longer context. I understand that GPT 4.1 can handle up to a million tokens of context.
This is one of the most exciting features of GPT 4.1. All the models in the family, GPT 4.1, Mini, and Nano, can handle up to a million tokens of context. And what this means in practical terms is that the AI can analyze, reference, and respond based on really, really extensive inputs.
What kind of documents are we talking about here?
So think about like entire legal contracts or massive code repositories. I mean, we're talking about documents that would take a human hours or even days to fully process and understand. With this kind of context window, the model can keep all that information in mind at once, which is just incredible for complex analytical tasks.
Are there any benchmarks that show how well it actually performs with all this context?
Absolutely. OpenAI has been testing it with benchmarks like OpenAI MRCR and something called graph walks, and both confirm that GPT 4.1 is substantially better than previous models at retrieving nuanced information from long inputs and performing what they call multi-hop reasoning, basically connecting dots across a really large document.
And have any companies put this to the test in real world situations?
Oh, yeah, and the results are pretty amazing. Thomson Reuters, which deals with tons of legal documents, reported a 17% improvement in legal clause cross referencing. And Carlyle, which is this massive investment firm, saw a 50% accuracy boost in extracting data from large financial reports. That's huge when you're dealing with, high stakes decision making based on complex documents.
So, what does this mean for developers? I'm trying to picture how I would use this in an application.
Great question. For developers, it's a game changer. Imagine building an application that can analyze an entire code base and identify security vulnerabilities or suggest refactoring approaches that take into account how different modules interact. Or think about a document management system that can answer questions about a 1,000-page contract without needing to chunk it up into smaller pieces.
Has OpenAI shared anything about how they achieved this? A million tokens seems like a lot to process efficiently.
They haven't given a ton of technical details. But what we do know is that they've made significant architectural improvements to handle this kind of scale. The impressive thing is that they've managed to do this while maintaining or even improving response quality and while keeping latency reasonable. It's not just about handling more context. It's about doing it efficiently.
I'm wondering about the costs. Traditionally, longer contexts have been more expensive to process, right?
That's actually another big update. OpenAI has eliminated the additional fees for long context usage, which used to be a major barrier for developers. So now the pricing is much more predictable and more affordable for applications that need to process large documents. This makes it viable for a lot more use cases that previously would have been cost prohibitive.
Could you give me a concrete example of how someone might use this in a business setting?
Sure. Imagine you're a law firm with thousands of previous cases and legal precedents. You could load entire case histories into GPT 4.1 and ask it to identify patterns or precedents relevant to a current case. It could analyze the relationships between different rulings over time and extract insights that might take a team of paralegals weeks to compile. Or in software development, you could feed in your entire code base and documentation, and new team members could ask questions to quickly get up to speed on how everything works together.
That's impressive. Are there any limitations we should be aware of?
Well, even with a million tokens, there are still practical limits. The model isn't perfect at retrieving every detail from very large documents, especially when information is presented in unusual formats or requires specialized domain knowledge. And there's always a trade off between context length and processing speed. But compared to where we were just a year ago, the capabilities they're just light years ahead.
So let's talk about these specialized variants of GPT 4.1. I'm really curious about the mini and nano versions. How are they different from the full model?
Oh, these variants are super interesting. So GPT 4.1 mini is basically it's like the middle child in the family, and it cuts latency in half while still maintaining intelligence that's comparable to GPT 4o. What's really cool is that you're getting almost the same level of smarts but with responses that come back to you much faster.
And what about the nano version? That sounds even smaller.
The nano version is it's absolutely fascinating. It's designed for like mobile applications and lightweight inference scenarios. It delivers responses in under 5 seconds, which is it's incredible when you think about it. And it offers the best price performance ratio of any OpenAI model to date. So you're getting this really efficient, really fast model that can still do impressive things.
What kind of use cases would make someone choose mini or nano instead of the full GPT 4.1?
Great question. For Mini, think about applications where you need that balance of intelligence and speed. So maybe customer service chatbots, where you need quick responses that are still smart enough to handle complex questions, or content moderation systems, where you need to process a lot of text quickly but still need good judgment.
That makes sense. And for nano,
For Nano, it's all about those situations where speed and cost are absolutely critical. So mobile apps are the obvious one. Users won't wait around for responses. But also think about, embedded systems, IoT devices, or applications that need to process tons of queries at scale. Like, imagine an e-commerce site that generates personalized product descriptions in real time during high traffic periods. You'd want something fast and cost effective like Nano for that.
are there any specific performance metrics that OpenAI has shared about these variants?
They haven't published comprehensive benchmarks for every task, but what we do know is that Mini performs at about the same level as GPT-4o overall, which is really impressive considering it's faster and presumably cheaper. And Nano, while obviously not as capable as the full model, still outperforms many competitors in its class.
So, how should developers decide which one to use for their applications?
It really comes down to it's about finding the right balance for your specific needs. If you're building something where accuracy and reasoning are absolutely critical, like let's say a legal analysis tool or a complex coding assistant, you probably want the full GPT 4.1. But if responsiveness matters more, like in a chat interface, Mini might be the sweet spot.
And I assume cost is a factor too.
Oh, absolutely. Cost is a huge factor for many developers. The Nano variant is going to be substantially more affordable for high volume applications. So if you're looking at, millions of queries per month, the difference in cost between the full model and Nano could be enormous. It's all about right sizing the model to your actual needs instead of just defaulting to the most powerful option.
Do these smaller variants still have the same million token context window?
Yes, that's one of the most impressive things about this whole family. Even the Nano version can handle up to 1 million tokens of context. The difference is more in how quickly and deeply they can process that information, not in how much they can hold in context at once. So even with the lightweight models, you can still work with those massive documents we were talking about earlier.
That's actually really impressive. I wouldn't have expected the smaller models to maintain that capability.
I know, right? It shows how OpenAI has really focused on making these models practical for real world use. They've clearly listened to developers who needed both long context and performance options. It's about it's about giving people choices without forcing them to compromise on fundamental capabilities.
So what about the pricing details? OpenAI usually makes a big deal about making these models more cost efficient.
Oh, they've definitely made some really exciting changes with the pricing. GPT 4.1 is actually 26% more cost efficient than GPT 4o on average, which that's a pretty significant improvement, especially for businesses that are running these models at scale.
That's definitely going to make a difference for developers who are watching their budgets.
Absolutely. And there's more good news. One of the biggest changes, and I'm super excited about this, is that long context usage no longer carries additional fees. Like before this, if you wanted to use those massive context windows, you'd have to pay extra for the privilege. But now, you can use the full million tokens without any surcharge, which is just, it's going to be a game changer for certain applications.
What kinds of applications would benefit most from that change?
Think about any application that deals with, massive documents. Legal tech companies analyzing entire case histories, research tools handling scientific papers, or code assistants working with large code bases. They all had to either pay those premium prices or find workarounds to avoid using long contexts. Now they can just use the full capability without worrying about extra costs.
Are there any other pricing updates that developers should know about?
Yes, the prompt caching discounts have increased from 50% to 75%, which is really generous. So if you're sending similar prompts repeatedly, which happens a lot in production systems, you're going to see way bigger savings than before. It's basically OpenAI acknowledging that a lot of applications have repeating patterns, and they shouldn't charge full price for work the model has essentially already done.
How do you think these pricing changes will impact adoption?
I think they're going to accelerate adoption significantly, especially for enterprise users who've been cautious about costs. These changes make it much more feasible to deploy AI at scale. What I'm seeing is that the cost per useful output is dramatically improving, like you're getting better results and paying less for them. That's going to open up use cases that just weren't economically viable before.
Do you think smaller companies and startups will benefit as much as the enterprise users?
Oh, 100%. For startups, every dollar counts, right? The improved efficiency of these models means they can build more sophisticated AI features without blowing their runway. And the specialized variants like Mini and Nano give them options to match their exact needs and budget constraints. It's actually it's democratizing access to really powerful AI technology.
What about those prompt caching discounts? How do developers actually take advantage of those?
It's pretty straightforward. The system automatically detects when you're sending substantially similar prompts and applies the discount. So developers don't really need to do anything special to benefit from it. The savings just start showing up in your usage reports. It's particularly valuable for applications that have standard user flows or templated interactions where the same kinds of requests come up repeatedly.
So, OpenAI is making these models both more powerful and more affordable at the same time?
That's exactly right. And that combination is what's really powerful here. We're not just seeing incremental improvements, we're seeing better models with more capabilities that also cost less to run. That's the kind of progress that really accelerates adoption and enables entirely new applications. Well, I think that's a great note to end on for this week's podcast. But I think you said you had an announcement?
I do. So, if you're serious about .NET and AI and ready to sharpen your skills at the source, don't miss Visual Studio Live, happening this August at Microsoft headquarters in Redmond, Washington. From August 4th to 8th, join fellow developers, Microsoft engineers, and industry experts for 5 days of deep dive hands on training. Whether you're building with .NET, Blazor, Azure, or tapping into the power of GitHub Copilot, ChatGPT, and the semantic kernel, this event puts you at the epicenter of modern app development.
I love this event. It's packed with practical sessions on everything from AI enhanced DevOps and cross platform development with .NET MAUI to cloud architecture and agentic AI workflows, all designed for working developers, not just enthusiasts.
It's more than just learning, it's a chance to connect, get inspired, and walk away with real tools to apply immediately on the job. Head to vslive.com to view the full agenda and register.
And that's it for this week's Pure AI podcast. Be sure to check out our ongoing coverage of all things AI at pureai.com. And also check out the newest feature on Pure AI, the Converge 360 Elevator Pitch video series, which features snapshot interviews with executives who explain what their companies do to their target customers, how they use AI to solve common business problems, and how to get in touch with them if you want to learn more.